what we're looking at here in the screen are our two nodes, Alice and Bob. And then we're also looking at a timeline of events starting at time 0. So we first see that Alice applies a Hadamard gate to her noise, and then to her qubit, sorry, and then that qubit is being sent over to Bob through the channel. And here is where Bob is receiving this qubit, and then we can see that actually Bob waits some time before sending it back to Alice. All right, and this happens, again and again during this simulation. And then to the right of the visualization, we can also see the values of fidelity that our qubit's it's taking, during this whole process. So what does this simulation look to you, Mike?
Well, I'm no quantum physicist, but what I'll tell you right now, Michelle, is it looks like I see the ping pong effect there, and I understand what that means now. It's bouncing the qubit back and forth. But one of the things that jumps out at me immediately is just from Alice to Bob, that duration of time, the fidelity, the resulting fidelity, I would imagine it starts at 1 with Alice, but then it drops pretty significantly to 0.949 once it gets to Bob. And then I notice there's also degradation from Bob back to Alice, and then Alice back to Bob. So to me, what jumps out, the only thing that looks like it's a factor there would be in between the memories, which the biggest thing there is the fiber optic cable. Mm-hmm. What could be causing that? Is it possible there's some issues with the fiber optic parameters that we got from the telco? Is there something maybe that they can improve there? What are your thoughts?
Yeah, so definitely this visualization is suggesting that there is something going on the, with the parameters that we established for the channel. Because, as you mentioned, we see that fidelity degrades as it travels, as it reaches the other node. So there's probably something wrong with that, parameter configuration.
So is it possible, maybe we go back to the telco and we say, we ran an analysis, a simulation, we visualized it based on the parameters you gave us. We think maybe there's some passive components that may have failed or have degraded, or maybe there's a bond that was created in the fiber optic cable repair that was done. It wasn't quite done properly, or maybe where the fiber optic cable is located. Send them back to go analyze that. And let's say they come back to us with, yeah, we found a problem with the passive component. We replaced it, we remeasured, and these are our new parameters. Would you be able to load those into the model now, Michelle, and rerun it?
Yes, for sure. Let's go ahead and do that and see how our network performs after, inputting these new configuration parameters. So let's say that after, the new probability for experiencing noise in the channel has lowered from 10% to 1%. So let's run this simulation again and see, if that actually helps us reach our goal. So let's run this, call it ping pong 2.log. Let's run the simulation and go back to our visualizer and see what we got. So we're gonna also, we're gonna again give it a network file first. We're gonna give it the log file that we just generated, ppong2, and we're gonna give it again the data collector file with the newly, with the updated fidelity values. So let's hit visualize, zoom in a little bit, and go down and see what happened in our simulation. So, okay, so what are you seeing now, Mike, with this new values?
Yeah, this made a huge, the adjustments to the channel depolarization noise probability based on the conduit, the fiber optic, that improves dramatically. Now it's just drops to 0.994 and then goes 905 to 88. So that looks great. But one thing that jumps out at me here, Michelle, is that it looks as though as the qubit is sitting in Bob's location and then sitting in Alice's location, Bob's location, boy, the fidelity really degrades there. It goes from, you got a great fidelity of 0.99, it drops down to 0.905 just over in Bob's location. And I would assume that's the memory itself. Is it possible that maybe we look at the vendor, the manufacturer of that memory, and say, do you have a little bit of a better maybe decay time or decoherence time available? Or maybe it's a different vendor that we select that has a better decoherence time. Is that possible? And are those things that we can actually choose from and get better parameters there to load into our model?
Yes, exactly. Let's go ahead and do that.